Have you ever wondered what it would be like to travel through time, to see the past or future firsthand? This question has sparked the imagination of countless individuals, from science fiction writers to theoretical physicists. The allure of time travel lies in its potential to unravel the mysteries of the universe and our existence within it. Time travel, as a concept, is a journey through time, either to the past or the future, in a manner analogous to moving through space. It's a compelling idea that has been the subject of many a science fiction narrative. But is time travel a mere flight of fancy, or could it actually be possible? To delve into the theoretical possibility of time travel, we need to understand the concept of space-time. In the early 20th century, Albert Einstein revolutionized our understanding of the universe with his theory of relativity. According to Einstein, space and time are woven together into a four-dimensional fabric known as space-time. This fabric is not flat, but curved by the mass and energy within it. Moreover, Einstein's theory suggests that the speed of light is a cosmic speed limit, a constant that cannot be exceeded. This has intriguing implications for time travel. If one were to move at speeds approaching the speed of light, time would appear to slow down. This concept, known as time dilation, suggests that under specific conditions, moving forward in time at least, might be within the realms of possibility. However, it's important to note that while time dilation is a well-established phenomenon, it's not quite the same as the time travel often depicted in popular culture. There's a vast difference between time appearing to slow down and actually hopping into a time machine to visit the dinosaurs or see what the future holds. So, while time travel remains a fascinating concept, it's not as simple as hopping into a DeLorean and hitting 88 miles per hour. The enigma of time travel continues to captivate us, a testament to our unending quest for knowledge and understanding of the universe we inhabit. Assuming time travel were possible opens the door to a host of paradoxes that challenge our understanding of reality. First, let's define what we mean by a paradox. A paradox is a statement or proposition that, despite sounding reasonable, leads to a conclusion that seems logically unacceptable or self-contradictory. Now, let's dive into two of the most famous paradoxes that time travel presents. The first one is the grandfather paradox. Imagine you've invented a time machine and you travel back to a time when your grandfather was a young man. If you were to prevent him from meeting your grandmother, your parents would never have been born, and consequently, neither would you. But if you never existed, how could you have traveled back in time to prevent your grandfather from meeting your grandmother? It's a mind-bending cycle that seems to defy logic, isn't it? The second paradox is the bootstrap paradox, named after the phrase, pulling yourself up by your bootstraps. This paradox deals with objects or information that is sent back in time, creating a loop in which the object or information has no discernible point of origin. For example, suppose you received a book from your future self, and then later, as an older person, you send the same book back to your younger self. Where did the book originate? Who actually wrote it? The book seems to exist in a continuous loop with no beginning or end. These paradoxes illustrate some of the complexities and challenges of the concept of time travel. They raise questions about causality, about the nature of time, and about the fabric of reality itself. But remember, these are theoretical problems based on our current understanding of the universe. As our knowledge evolves, who knows? We might one day find a way to resolve these paradoxes. These paradoxes present mind-bending scenarios that seem to defy logic and challenge the very concept of time travel. Despite these paradoxes, some theorists have proposed potential solutions and alternate theories. Let's delve into some of them. One fascinating proposition is the many worlds interpretation of quantum mechanics. This theory suggests that every decision creates a new parallel universe. Imagine you're deciding whether to have coffee or tea. According to this interpretation, there's a universe where you chose coffee and another where you chose tea. Now, apply this to time travel. If you went back in time and changed something, you wouldn't create a paradox in your original universe. Instead, you'd create a new parallel universe reflecting that change. How's that for a mind bender? But what about the mechanics of time travel itself? How could we possibly achieve it? This is where cosmic strings and wormholes come into play. Cosmic strings are hypothetical one-dimensional defects in the fabric of the universe. They are incredibly thin, yet unimaginably dense. Some physicists believe that if these strings exist, they could be manipulated to create a loop in time. Similarly, wormholes are another potential method for time travel. Inspired by Einstein's theory of general relativity, wormholes are bridges through space-time, connecting two distant points in the universe. Some theories suggest that if a wormhole could be stabilized, it could potentially facilitate time travel. But here's the catch. Cosmic strings, wormholes, and even the many worlds interpretation are all just theories at this point. They are intriguing concepts that push the boundaries of our understanding of the universe. They offer potential solutions to the paradoxes of time travel and tantalizing possibilities for the future. But as of now, they remain in the realm of the theoretical. While these theories are intriguing, they remain purely theoretical and have yet to be proven or disproven. The quest for understanding time travel continues, and until then, we'll keep exploring, questioning, and dreaming of the possibilities. So, where does that leave us in regards to time travel? Well, it's a fascinating question, isn't it? The very idea of stepping into a machine, pressing a button, and emerging in another era is exhilarating. But what does science have to say about it? As it stands, the scientific consensus is somewhat divided. On one hand, we have the theory of relativity, which does not rule out the possibility of time travel. It suggests that space and time are intimately connected into what we call the space-time continuum. Einstein's equations do allow for solutions where time loops back on itself, theoretically, allowing for time travel into the past. On the flip side, we have quantum mechanics, which governs the world at the smallest scales. In the quantum realm, there's a degree of uncertainty that seems to resist the definitive timelines required for time travel. These two great pillars of modern physics don't quite agree when it comes to time travel, reflecting our incomplete understanding of the universe. Now let's consider our current technology. We're far from building a working time machine. The energy and materials required, according to our current understanding of physics, are beyond our reach. Think about harnessing the power of a star or finding exotic matter with negative energy. It's like trying to build a skyscraper with Stone Age tools. Beyond the scientific and technological hurdles, there's a whole other dimension to consider: the ethical and philosophical implications. If time travel were possible, how would we deal with the potential for altering history? What about the paradoxes that could arise? These questions delve into the realms of morality, responsibility, and the very nature of reality itself. While the possibility of time travel continues to captivate our imaginations, for now, it remains firmly in the realm of science fiction. But who knows what the future holds? Science is always advancing, always exploring the unknown. And perhaps one day, we may just find a way to traverse the river of time. Until that day comes, we can only speculate and dream. Let's take a moment to recap what we've learned about time travel. We've delved into its enigma, exploring the paradoxes that make it a complex concept. We've also looked at potential theories, some suggesting solutions to these paradoxes. Lastly, we delved into the reality of time travel, highlighting the scientific evidence that supports its feasibility. While time travel remains a tantalizing concept, it's clear that we still have a long way to go before we can start planning trips to the past or future.